First quarter review number 16 through 20. 16 asks which graph best represents the motion of an object in equilibrium. What do we need to know? If you're in equilibrium, you have no acceleration, which means we're looking for a constant velocity. Okay, these are all graphs of displacement or position versus time. And on those graphs, the slope equals velocity. So we want to find a graph where the slope, okay, actually I'm just looking at graphs A and B are displacement time. So we're looking for a graph where displacement time shows a constant slope for a constant velocity. That's a line that looks like that. Choice B, let's look at the wrong answers. Choice B looks like that. That has a slope getting steeper and steeper and steeper. This guy is accelerating. The second two graphs are velocity versus time. Let's look at why those are wrong. V versus T. Choice C has a velocity that's constantly going faster and faster and faster. That's accelerating. And choice D is just pure craziness. That shows a velocity that's getting bigger at an increasing rate. That's never going to be a right answer on a Regents exam. What do you think about that? That's actually like an increasing acceleration. Okay, moving on to number 17. Basketball player runs, this is silly, back and forth 3 times. So back and forth once is 60 meters, because they go 30 meters and then 30. You do that 3 times, and you get 180 meters is the total distance traveled. We want the average speed. This time V stands for average speed. I want distance of 180 meters over 60 seconds is 3 meters per second. Keep in mind, if they had asked for average velocity, it would be 0 because the displacement is 0 because you end up where you started. But they didn't. They asked for speed. Number 18. Another distance displacement one. Okay, here's home plate. Here's first base. The player runs 27.4 meters. That's 66 feet or something. 27.4 meters to first base. That's 27.4 meters. Then goes 3 meters over running it, so 3 meters more, and then comes back and ends up back at first base. So compared to the total distance is 27.4. Distance is 27.4 meters plus 3 meters over running plus 3 meters to get back gives you a grand total of 33.4 meters. The total displacement is from start to finish, which is first base, and that's 27.4 meters. So displacement is 27.4 meters east or whatever it is, but they just want the magnitude. So 27.4 versus 33.4, the distance is 6 meters longer. That is choice D. No, I'm sorry, my bad. Compared to the total distance, which is 33.4, the displacement is shorter by 6 meters. So it's choice B, B. Okay, moving on, 19. Give me more room, 19. Car traveling in a straight line. Decreases, okay, I'm going to up it. Keep track of all these velocities. From 30 meters per second, that's VI, 30 meters per second, to 23, VF is 23 meters per second in a time of delta T of 2.0 seconds. And these are west. They want average acceleration equals question mark. Looks like we're clouding here. West is positive, east is negative. Cloud that bad boy. Calculate acceleration, VF minus VI over delta T. My VF is 23, that's west, so it's positive 23 meters per second, minus positive 30 meters per second, all divided by 2 seconds. I do the math, and I get negative 3.5 meter per second squared. The minus sign means it is east, and so it is 3.5 meter per second squared east, which is choice A. As I'm about to do number 20. Here comes number 20. An object accelerates uniformly. Well, this is the same thing we just did. Up, it, out. VI is 3 meters per second east. VF is 8 meters per second east. Delta T is 2.0 seconds. And they only want the magnitude anyway, so I don't care about the direction. I'm not going to cloud anything. A is VF minus VI over delta T. Final, 8 meters per second minus 3 meters per second divided by 2.0 seconds gives me an acceleration of 2.5 meters per second squared. Happens to be east, but they don't care, so I don't care. That is choice A. A. Okay, the end.